Okay, so apparently I was very wrong, but not for all the reasons I guessed. This is another example of why I listen to experts with an open mind and don't assume I know enough to pwn them. Sadly, like with the issues of trying to disprove evolution or thinking you have a slam dunk argument against man-made climate change or for anti-statism or racism, the experts are about 500 steps ahead of you and have already taken your ideas into consideration probably long before you were born. Of course, if you believe in any of these arguments, you probably assume that you're way smarter than me to begin with, or I just have a religious-like faith in any of these other systems. Most people just made the argument that human interference with the weather would probably have some form of butterfly effect and they would just mess up nature more. Besides the fact that that was the same argument they had against stem cell research and genetic engineering, which both hold some merit, it's really no worse than what we're doing to the environment already. Greisky also posted this rebuttal. The prediction horizon of the weather is currently about 10 days. I assume that that's what you would call the butterfly effect. 10 days is enough to do something. Perhaps it helps to know that for any chaotic dynamic system, such as the atmosphere, the ability to predict the state at some time in the future depends on the accuracy to which the initial state is known. Suppose that there is a small difference between the assumed initial condition and the real state at the start of the calculation. The difference will grow exponentially in time until it's no longer small. The growth exponent is called the Lyapunov exponent. This is a characteristic of the dynamic system and thus not really something you can change. You can change the initial difference by obtaining more accurate sets of measurements, thus more weather stations. No one made videos, but I had several people rip my arguments to shreds, not because it was a bad idea overall, but from a technological standpoint I was completely unaware of. So I will read some of their arguments, the first ones being the most eye-opening to me. Blurglide, who has a BS in mechanical engineering and 10 years in the aerospace industry, wrote this one. This was an area I hadn't even suspected there would be trouble with. Balloons have a limited duration. During the day they get hot. Pressure goes up and they have to vent. At night they need to replenish the vented gas. Compressors sufficiently fast to store it would take up most of your payload. This is much easier on Venus since the atmosphere is so dense it makes it easier to get things to float. You can even float metal balloons there, which can handle much greater pressure differentials. I responded, even helium? I assumed it would run on a passive system, cool down would drop their altitude, and they'd reach their peak levels at the hottest part of the day. And he goes, yep, PV equals nRT, the ideal gas law. When it gets hot, it expands, and you need to either compress it, vent it, or have a balloon strong enough to contain the enormous forces. This is one of the biggest challenges to long-duration balloons. We are getting better at building them, though. Forget using helium, though. There's not enough of it, and it's very expensive. Filling a man-carrying helium balloon costs thousands of dollars. Hydrogen and helium both leak, since they're so tiny, too. We do have balloons that can contain the pressure, super pressure balloons, but the strength makes them heavier and reduces the payload. You'll need a propulsion system, and it has to be big for a spherical balloon, the easiest shape to contain the pressure and to make the lightest balloon. You could build these and block out some small percentage of the sunlight, but the scale would be gargantuan to be effective, and forget about cooling small patches of ocean. It takes a long time and heat is replenished via currents. Don't forget, hurricane clouds already shade the water. For scale, about 1% of the U.S. has been paved over. If you want to reduce heat load by 1%, you need enough balloons to cover an area equivalent to the roads, parking lots, and paved areas of the entire country and manage to have them all flying at the same time. Ocean currents keep Europe warm. Water is an enormous heat sink. It takes huge amounts of energy to change the temperature of water. Look at the military for balloon technology. They would love to be able to park a recon and comm balloons over one spot for the duration of a war, but it's really hard to keep them up there for very long, let alone in one place. So they have to wait for satellites to pass over or fly a UAV around in circles for a few hours. Also, some other ideas to block solar radiation are giant ships that spray seawater in the air, making clouds. Gates Foundation is funding some research into this, and also spraying sulfide compounds at high altitude, which could reflect radiation. Just FYI, you could make balloons with mylar tops, if high enough, could reflect heat back into space. heat is important if you want to cool the air and not just the ground. Otherwise, just lay Mylar on the ground like you do in some ski areas. We just don't have the tech to keep them where we want them, so you'd have to recover them where they land, and you need a lot of them to affect global temp. MichalChik wrote and provides links, which will be included with this and the entire script in the bottom bar. What I can say is your basic idea is feasible if you replace blimps with stratospheric aerosols, which is what all geoengineering stuff is about. One plane can generate the shade ability of a balloon in a fraction of a second and for pennies. The main problem I see are in the technical details, Mother Nature's uncooperativeness, and the scale. The balloon would tend to drift to jet stream levels in the atmosphere, which would mean they would be pushed along at hundreds of miles per hour in unpredictable directions. The difficulty of steering a balloon increases proportionally to its cross-sectional area. 1,000 balloons to cover a square kilometer is roughly 1,000 meters divided by the square root of 1,000, which is 32-meter diameter balloons, or 104 feet, which makes each one wider and more than half as long as a Goodyear blimp. The latest Goodyear blimps cost around $21 million. Hurricanes are huge. Take a small one with a radius of 100 kilometers and you would cover the area of pi r squared, or 30,000 square kilometers. That would mean 30,000 times 1,000 is 30 million of your balloons. At $21 million a balloon, that would be about $63 trillion. Raven Dirksen, who's a junior-level mechanical engineering student, wrote, "A hurricane is essentially the cyclone that you're describing. Hot air from the deserts in Central Africa move over the Atlantic Ocean. The cold temperatures of the Atlantic Ocean, coupled with the hot air, creates a system that seeks to balance the temperature between the two. By the time the system reaches coastal waters, the water has cooled the air to some degree and the rotation continues, with the air now cooler than the water above it and changing barometric pressure. Warmer water now feeds the system, increasing rotation." Alatari wrote, "The smallest hurricanes are listed as 200 kilometer radius, so we're talking over 125,000 kilometers squared for even the smallest ones. 1 kilometer squared would not be sufficiently large enough to diffuse it." Response to that in this video is, if it wasn't for ocean currents, you wouldn't need a complete blackout, just enough to reduce the temperatures some, but with currents constantly feeding the area with new heat, a complete blackout would probably be needed. So guys, totally pwned on this issue, but apparently several other people have been wondering about this question as well for a while. If this has any merit at all, it's a piece of future tech that will probably start out as painting all the roofs and roads with reflective paint, as the Energy Secretary recommended. When stronger and lighter and less porous materials are cheap enough in 10 to 20 years, it might work on land, but certainly not in the oceans. Also, we need more powerful solar panels to affect direction. With the advance of nanotech, however, these balloons might take some tips from cells and have selective pores built in to regulate the types of gas entering and vent when the temperature and pressure reach certain levels. By that time, who knows, we may find tiny precise cooling points in our weather and ocean current models that will be able to be used to affect the direction or strength of the storm with little cooling efforts. So, totally pwned. The tech is at least 20 years away and the military will be all over that technology as soon as it's possible. I spent the entire day going through a paradigm shift, and at the moment, just like what happens with religion, my brilliant idea is actually not so brilliant. Growing up, I used to believe that if I couldn't think of a way that it could be wrong, then it must be right. Yay, argument from ignorance. When people would attack the argument with facts I'd never thought of before, it really pissed me off and hurt my pride because it was so perfect that it had to be true. That is the major reason why I take such neutral and non-confrontational stances on this channel and just present evidence. Many people link their knowledge or ideas to their self-worth, and to attack their ideas is attacking them. I've had my beautiful and perfect ideas destroyed enough and my pride hurt enough that this had no effect on my confidence or in my self-worth. Though it has shown me that I'm just the tiniest bit less special than I thought I might be. That's what I love about YouTube. I can ask experts in their fields I'm barely an amateur in and get the right answer. And you all can learn something in the process too. Thanks for the schooling, everyone. I'm just a little bit smarter today.